Hello everyone, I'm Aya, and today we will talk about my project on Sustainable Development Goal number 7, affordable and clean energy. I'm using it to compare Bahrain's current gas-fired electricity grid with a future alternative, utility scale solar power. SDG has 5 targets: universal energy access, more renewables in the mix, doubling energy efficiency gains, and international cooperation and framework for clean energy. Globally, 685 million people still lack electricity, and renewables are only 18.7% of final energy use. Bahrain already has universal access. Its challenge is targets 7.2 and 7.3. Its grid is 99.7% natural gas, and it uses about 22,700 kilowatts of electricity per person each year, one of the highest rates in the world. Bahrain's current system runs on 5,444 megawatts of gas capacity, generating around 90,000 gigawatts per hour a year. Using a typical emission factor of zero point 0.3 to 0.45 tons of CO2 per megawatt hour, it's roughly 7 to 8.5 million tons of CO2 a year just from electricity. It's extremely reliable. Bahrain's outage time is far below the world average, but it's a single fuel system exposed to gas prices and far from Bahrain's own climate targets. The future alternative is solar PV. A planned 100 megawatt plant like the one at Askar at a 19% capacity factor would generate about 166,000 megawatt hours a year, avoiding around 66,500 tons of CO2, equivalent to taking roughly 14,000 cars off the road. And solar is now cheap. The global average cost is about 200 fils per kilowatt hour, and the region's record low in Abu Dhabi is just 500 fils. Solar can't fully replace gas yet, though it is unsteady, so Bahrain's plan is a managed transition: 20% clean energy by 2035, over 45% by 2040, with gas as flexible backup while solar and eventually storage scale up. To ground these numbers in real evidence, I ran a structured data collection and validation process. For every key figure, grid capacity, emissions, solar cost, and output, I cross-reference UN Energy Statics, Bahrain's electricity and water authority reports, and international sources like the IEA and IRENA, where sources disagreed. I resolved it is using the most recent authoritative figures and logged every data point with its source title, publication date, and URL. So the numbers you have seen are fully traceable rather than just assumed. That trans- this, trans- this transition also raises real ethical questions. Using the energy justice framework, I looked at three things: who bears the cost and who gets the benefits of Bahrain energy system, whether affected communities get a real say in decisions like where solar farms are built, and whatever vulnerable groups like the low income households or migrant workers who can't afford rooftop solar or efficient air conditioning are being recognized and protected as the country decarbonizes. Finally, I ran a short awareness session with 11 people to explain SDG7, my data collection findings, and checked their understanding with a 6 question quiz. Overall accuracy was 84.8%, and everyone correctly identified the gas grid's reliability advantage. The one gap I noticed was around Bahrain's actual dependence. Several people underestimated it, which told me that even though the numbers are public, they are not widely known. If I run this again, I'd spend more time on the specific stat that track individual responses rather than just the group average. You can see the quiz results on the screen after. In summary, Bahrain's gas-fired grid is reliable but carbon-intensive. Solar PV is now cheap and clean but unsteady, and the sustainable path forward is a fair, gradual transition between the two. Thank you all for watching, and I added appendix or for the resources I have put in this presentation. Thank you very much.